Okay, so today we're going to show you how to graph quadratic functions. Here's what I want you to do. I want you to stop the video right now. Pause it. I want you to copy everything down that we have right here because you're going to get a question really quickly about what that x equals negative b over 2a is. Okay, so you're back, and let me show you what we're talking about. Actually, I shouldn't have probably asked that question. I don't think I will. But anyway, back to my train of thought here. Here's the deal. Right here, quadratic functions, we're going to do some graphing. They are parabolas. Parabolas have a vertex. This is where this thing comes all the way down and stops and then starts back up. It's the turning point. All right, it has an x and a y value. Somewhere on the graph in x and y, there's a turning point. The x is the line of symmetry. There's a line of symmetry that goes right down here. And this line of symmetry is x equals whatever this x value is. Okay, because x equals some value is a vertical line. That's the line of symmetry. It splits it in half. The y value gives the minimum point or the maximum point. Now, in this case, this is a minimum point because it curls down and goes back up. This is as low as it gets on the y value. If this parabola is shaped like this, then this is the maximum point. It's as high as it gets. I'm going to erase that. I don't really need that. But I'm just going to tell you that's in class. We'll show you that a little bit. All right. Now, to find the x-coordinate of the vertex, we use this equation. X equals negative b over 2a. To find the y-coordinate, we're going to show you sub it back into the quadratic. And we'll show you that here in a second. You'll understand that totally when we show you. In fact, I'm going to show you that right now. All right, here we go. I've actually paused the video right here and do some copying down, and we'll show you what we're talking about. Okay, so let's get a good pointer right here. Okay, so what we're doing is we're going to graph this negative x squared, y equals negative x squared plus 6x minus 5. Well, you know you could choose any x. Like I could choose 1, stick it in here, and I could get an xy point where this graph, where x is 1, I could find out what y is by subbing it in here, but we're not going to do that. Okay, that's too much guess and check. So what you have to do is you have to find out where this thing is, where the vertex is, where it turns and goes the other way. Because if you find the vertex, it's symmetrical on the left-hand side of the vertex as it is on the right-hand side. So what we do is, to find the vertex, we stick these numbers in here. Remember that this number is A, this number is B, positive 6, and negative 5 is what we would consider to be C. Okay, so that's what we're going to stick into this equation, opposite of b over 2a. Well, b is positive 6, the opposite of positive 6 is negative 6, over 2 times a. A is a negative 1, so we put negative 1 in. So we got the x-coordinate of the vertex is negative 6 over negative 2, which is positive 3. So I made a chart. What I'm going to do is I'm going to make this chart. I'm going to put 3 in here in the middle value of x and find out what the vertex is. So I'm going to stick into this equation negative x squared. So I got 3 squared is 9. Negative, that's negative. Plus 6 times 3. Okay. Minus 5, all right, and I find out that the vertex is at 3, 4. So 1, 2, 3, up 4. 1, 2, 3, 4. Here's the vertex right here. Okay. Since I know that's the vertex, I'm going to see what y is when x is. I'm going to pick two sides on either side of the vertex. So what y is when x is negative or 2, and what y is when x is 1. I'm also going to find out what y is when x is on two sides of right of the vertex, when it's 4 and when it's 5. So let me show you how we did that. We said, since it's the vertex, I'm going to also use 2 in for x. I'm going to use 1 in for x. I subbed it into this equation right here as far as my middle column in my chart, and I found that when x is 2, y is 3. When x is 1, y is 0. So I'm going to plot those points. All right, so I'm going to plot the point 2, 3. So right 2 up 3. This point right here. I'm also going to plot the point 1, 0. So 1, 0 right here. All right. This is half of the parabola. Now I'm going to tell you that this other half right here is symmetrical, but you can sub it in. All right. We're going to use the points 4 and 5, and when we use the points 4 and 5, we get the point 4, 3. So 1, 2, 3, 4, up 3. Wait, 1, 2, 3, 4, up 3. Here's a point. And then I get the point 5, 0. So 1, 2, 3, 4, 5, 0. Right here. Okay, there's several things you got to pull from this. All right? You got to pull what the vertex is. The vertex is at the point 3, 4. We have a maximum value. That's the biggest y. The maximum value is 4. That's the y value in the vertex. We have a line of symmetry that goes right here. That line of symmetry is x equals 3. That's what you're going to find in today's lesson. I'll show you more during class, but that's basically it.
Made with Doodlecast Pro.